A Gulf Coast nurse wakes at 5:42 a.m. to her phone vibrating on the bedside table. Outside, the street is dry, the air feels heavy, and nothing looks wrong. The emissions stop first. The warming does not. Oceans and ice respond too slowly to care about political timing. Earth is already about 1.1 degrees Celsius warmer than the pre-industrial baseline. And the last 10 warmest years on record all happened in the past decade. Sea level is up 8 to 9 inches since 1880. For a low street, a school zone, or an evacuation road, that background rise means failure starts sooner. What closes that gap now is not one machine. It is a chain. Satellites read sea surface temperature and cloud structure. Radar tracks rainfall motion. River gauges and soil sensors report what the ground can still absorb. AI models fuse those streams and estimate where water will arrive, block by block, before human senses can see the threat. But what happens when even that arrives too late? The real question is harsher than most climate messaging admits. If all new carbon emissions stop today, why would the planet still keep warming for roughly 2 to 3 more decades? And can forecasting systems help people survive damage already set in motion? If this kind of first principles science fascinates you, CivilizationX is the channel for it. Now, let's look at the mechanism. Climate lag is a physics problem. Greenhouse gases reduce how much infrared heat Earth can radiate back to space. Carbon dioxide is now about 50% higher than before the Industrial Revolution. More than 90% of that excess heat goes into the ocean, not the air. That makes the ocean a giant thermal battery. It charges fast enough to matter and discharges slowly enough to haunt us. Warm water expands. So sea level rise is not only melting ice, it is also the ocean physically swelling. Then ice retreats. Darker water and land absorb more sunlight, and the Arctic warms at least twice as fast as the global average. Between 1979 and 2021, the Arctic lost about 31,100 square miles of sea ice per year. But here's the part people miss. Turning off the source does not instantly stop the effect. A cast iron pan keeps burning after the stove is off. Climate works the same way, except the pan is the ocean and the delay is measured in decades. That is the hidden cue. Future heat already moving through water, ice, and air. It shows up as stronger extremes because warmer air holds more water vapor. Storms can dump more rain in less time. Hurricanes, flash floods, and other extreme precipitation events become more destructive. And about 74% of natural disasters between 2001 and 2018 were water-related. That is why a dry street can still be under real flood threat before sunrise. AI helps by compressing decision time. Forecast systems ingest satellite imagery, Doppler radar, topography, drainage maps, stream gauges, and sometimes traffic and power outage data. Models then estimate flood depth, wildfire spread, or storm impact at neighborhood scale. Similar machine learning systems are now used to optimize power grids, balance renewable supply and demand, and detect methane plumes from space. In some cases, methane monitoring has identified emissions far higher than earlier inventory suggested, including estimates roughly 4 times higher for specific sources. AI is also being used to search battery chemistries and carbon sequestering concrete, which matters because buildings and construction produced 37% of global operational energy and process-related emissions in 2022. But prediction is not protection. A perfect alert can still need undersized drainage, no car, weak cell coverage, no paid time off, or a road that floods first in the poorest neighborhood. But here's the problem. Affluent districts get denser sensors, stronger substations, and elevated homes. Renters in low-income coastal or river neighborhoods often get the same warning with fewer exits. So yes, advanced systems can reduce harm. They can warn earlier, route power better, find methane faster, and cut emissions by improving grids and infrastructure. Some estimates put AI-enabled emissions reductions at 5 to 10% by 2030. But they do not cancel climate lag. Geoengineering does not solve the governance problem. Large AI systems also consume energy, can encode bias, and can become an excuse to delay the harder work of cutting fossil emissions now. The next decade is an engineering race on 2 tracks. adapt faster, and emit less. Delaying peak emissions by 10 years can add about 0.5 degrees Celsius by 2100. Meanwhile, climate change is projected to cause about 250,000 additional deaths per year between 2030 and 2050 from heat stress, malaria, diarrhea, and undernutrition alone. The near-term target is clear: smarter grids, faster methane abatement, lower carbon materials, and hyper-local warning systems deployed where vulnerability is highest. Back on that Gulf Coast morning, the alert gave the nurse just enough time to move her car, wake her son, and leave before the road disappeared. The system did not stop the flood. It translated delayed planetary physics into a few usable minutes. The open question is whether forecasting systems can stay accurate and trusted when the baseline climate itself keeps shifting and the past stops being a reliable training set. Which matters more now? Building better prediction or building places where a warning can still be acted on? The constraint is real. The data exists. Whether the systems built around it can act on it at scale, that is the next engineering problem. Stay with Civilization X.